Scientists just detected something under Yellowstone that should not be happening. The ground is rising. Thousands of hidden earthquakes have appeared, and a massive fault near the park has not ruptured in thousands of years, but may already be loaded for a major earthquake. 4 million people visit Yellowstone every year. Most of them have no idea what they are standing on. And what scientists are seeing right now could reshape the entire region overnight. This is not about the super eruption. That is not what is keeping researchers awake. What is keeping them awake is something much more likely, much less understood, and already showing signs of movement. In July 2025, GPS stations near Norris Geyser Basin started behaving strangely. One drifted southwest, another shifted northeast. Both moved away from the same invisible point underground, as if something beneath them was inflating. By October, satellite radar confirmed it. The ground along a 19-mile stretch of the Caldera rim had risen, and with the uplift came earthquakes, over 100 in a single month, concentrated directly around the zone of deformation. The USGS calls this the Norris Uplift Anomaly. It happened once before, starting in 1996. Then it stopped. For 20 years the ground was quiet. Now it is back. The source sits roughly 9 miles down. That is the depth of Yellowstone's magma chamber. And the ground is not just rising, it is pushing outward from a single point, the exact pattern scientists see when magma starts accumulating beneath the surface. But here is what makes this time different. Scientists now have a tool that did not exist 20 years ago, and what it found changes everything. Researchers fed 15 years of Yellowstone seismic data into a machine learning system designed to detect earthquakes too small for conventional instruments. The AI scanned every waveform recorded between 2008 and 2022. The results were published in the journal Science Advances in July 2025. What they found stopped the scientific community cold. The AI identified 86,000 earthquakes, 10 times more than anyone knew existed. 86,000 tremors that human analysts and standard instruments had missed entirely. 15 years of hidden seismic activity, invisible until a computer went looking for it. And more than half were part of swarms. Clusters of interconnected quakes moving through the rock, driven by superheated fluid forcing its way through the crust. The fault structures beneath the caldera were not smooth and predictable. They were jagged, chaotic, immature, still being actively reshaped by water and gas at extreme temperatures. Yellowstone is not quietly resting between eruptions. It is seismically churning at a scale nobody knew about until this year. But the most disturbing part of this discovery was not the number of earthquakes. It was what the system has already proved it can do. Because the most devastating event in Yellowstone's recorded history was not an eruption. It was an earthquake on a nearby fault. And what it did to the park happened in a single night. August 17, 1959, 11:37 at night. Peak tourist season. Around 250 people are sleeping in campgrounds along the Madison River, just outside the park. The night is calm, clear. Then the ground tears open. A magnitude 7.3 earthquake strikes near Hebgen Lake. The shock is felt from the Pacific coast to North Dakota. The shaking lasts over 30 seconds. Fault scarps appear overnight with up to 20 feet of vertical offset. Hebgen Lake tilts so violently that waves surge back and forth for 12 hours, breaching the dam repeatedly. Tourists downstream thought the dam had failed. But the shaking is not what kills people. What kills people is what the shaking sets free. On the south wall of Madison Canyon, a section of mountain 1,300 feet high detaches. 80 million tons of rock accelerate down the canyon at over 100 miles per hour. The landslide generates winds as strong as a hurricane, strong enough to toss cars. It sweeps 430 feet up the opposite wall. The entire collapse takes less than a minute. Rock Creek Campground, at full capacity, is directly in the path. Buried. The debris dams the Madison River completely. Water starts rising behind it, forming what is now Earthquake Lake. Survivors spend the night trapped on a high point they later name Refuge Point. 28 people die. 19 bodies are never recovered. They remain beneath the slide 66 years later. One survivor described waking to a different planet. The road out was buried under rock in one direction and had collapsed into the lake in the other. 300 people were trapped in the canyon with no way out. Smoke jumpers parachuted in at dawn to establish communications. Air Force helicopters arrived by midday to evacuate the critically injured. A rough road was bulldozed around the landslide by late afternoon. But those 19 bodies are still there right now, under the debris. The Forest Service built a visitor center directly on top of the slide. Tourists stand on it every summer. And then something even stranger happened. Inside Yellowstone, the earthquake rewired the hydrothermal system overnight. Within 24 hours, 289 hot springs erupted as geysers. 160 of them had never erupted before. Hundreds more turned turbid. New fractures opened in the ground. New fumaroles appeared. Trees began dying in lines along newly created underground heat channels. Sapphire Pool, a quiet spring in Biscuit Basin, was transformed into a geyser throwing water 150 feet into the air. Eruptions 200 feet across. It kept going for 9 years. One earthquake on one nearby fault reorganized the behavior of thousands of thermal features simultaneously. The underground plumbing of Yellowstone is not fixed infrastructure. It is a reactive system that can be catastrophically rearranged in a single night. And that was not even the most dangerous fault near the Caldera. This is where it gets worse. 44 miles south of Yellowstone sits the Teton Fault, one of the most dangerous faults in the western United States. It runs the entire length of the Teton Range. It is the reason those mountains exist. It has not produced a major earthquake in recorded history, which sounds reassuring, until you realize what that actually means. The geological record shows the Teton Fault is capable of producing a magnitude 7.5 earthquake. The last major ruptures were roughly 5,000 years ago and 8,000 years ago. The estimated recurrence interval is somewhere between 1,600 and 6,000 years. Do that math. Even at the longest estimate, the fault is within the window. At the shortest, it is overdue. A fault with a high slip rate and a long silence is not dormant. It is storing energy. Every year without a rupture adds to the strain. And unlike the well-studied San Andreas in California, the Teton Fault has received a fraction of the research funding and public attention. Most people who visit Grand Teton National Park have never heard of it. And here is what almost nobody outside of geological research understands. The Teton Fault is not independent of Yellowstone. The Yellowstone hotspot created it. The same forces that thin the crust above a rising mantle plume pull the surrounding landscape apart. The volcanic plateau pushes outward. The crust stretches. Faults form. Research confirms the hotspot directly changes the stress on surrounding faults up to 50 kilometers from the Caldera. The Teton Fault sits inside that radius. Every cycle of uplift and subsidence in the Caldera shifts the stress balance on the Teton Fault. Every pressure change in the magma system below nudges it closer to or further from failure. The two systems are not neighbors. They are connected. And one of them just started moving again. Jackson Hole sits directly on the side of the fault that drops during a rupture. The town of Jackson, the ski resorts, the airport. Billions of dollars of real estate in a valley that was not built to the seismic standards of California or Japan. A major Teton earthquake would produce severe shaking across the entire valley and could trigger liquefaction, where saturated soil behaves like liquid, collapsing foundations and swallowing roads. Infrastructure that was designed for a geologically quiet environment would face forces it was never built to withstand. And right now, this loaded fault sits next to a caldera where the ground just started rising again, where 86,000 hidden earthquakes have been churning through immature fracture networks, where magmatic activity 9 miles down is actively deforming the surface. Now think about what the 1959 earthquake taught us. A magnitude 7.3 earthquake on a nearby fault rewired thousands of thermal features inside the park overnight. Geysers erupting where none had existed. Steam vents opening in new locations. The entire hydrothermal system rearranged. If a magnitude 7.5 earthquake struck the Teton fault today, the seismic energy would reach the Caldera within minutes. Based on 1959, you would expect the same kind of overnight transformation. Except this time, 4 million people visit the park every year. Boardwalks are positioned over thermal features mapped under the old configuration, and the hydrothermal system is already showing signs of change. So now let us talk about what Yellowstone is actually doing right now, because the signals are not theoretical, they are visible, and they are accelerating. In February 2026, Steamboat Geyser, the tallest active geyser in the world, erupted at Norris for the first time this year. In the same month, Geyser, dormant since December 2020, erupted approximately 40 times. 40 eruptions from a geyser that had been silent for over 5 years. The hydrothermal system at Norris, sitting directly above the zone of renewed uplift, is changing its behavior in ways that are measurable, documented, and ongoing. In July 2024, a hydrothermal explosion at Biscuit Basin blew a crater in the ground and sent rocks and boiling water into the air. Tourists who had been standing feet away ran for their lives. The USGS installed a dedicated webcam at the site the following year. When the Geological Survey installs a permanent camera to watch a single pool, that tells you everything about their level of concern. In March 2025, a brand new steam vent was discovered near Nymph Lake. Steam at 171 degrees erupting from the base of a wooded hill where no thermal feature had ever existed. The USGS scientist in charge described new thermal features appearing as mundane. That word is important. It means the ground at Yellowstone changing beneath your feet is so routine that the people who study it no longer find it remarkable. The park radiates more thermal energy than multiple nuclear reactors combined. Continuously. It contains over 10,000 thermal features. New ones appear. Old ones vanish. The system is in constant, unpredictable flux. And beneath all of it sits not one magma chamber, but 2. To understand the scale of what we are dealing with, consider this. Yellowstone has produced 3 super eruptions in the last 2.1 million years. The largest ejected 6,000 times the volume of Mount St. Helens. Ash from that eruption blanketed more than 15 states and was found in deep-sea drill cores 1,000 miles away in the Pacific Ocean. The most recent super eruption, 640,000 years ago, spread debris across 21 states and punched an eruption column to the top of the stratosphere, altering global climate for years. The chance of that happening again in any given year is about 1 in 700,000. That is the number scientists give, and it is accurate. But the super eruption is not the threat they are watching. The threat is the system itself. The old image of Yellowstone, a single magma chamber under a caldera, is 20 years out of date. In 2015, seismologists revealed the full picture. 2 chambers stacked like floors in a building, connected by a network of conduits channeling molten rock upward from a plume that reaches the boundary between the Earth's core and its mantle, over 1,000 miles straight down. The upper chamber is large enough to fill the Grand Canyon 2.5 times. The lower reservoir is 4.5 times larger than that. The combined volume of liquid magma in both right now is comparable to the explosive material from the last 3 super eruptions combined. Nobody is predicting a super eruption. The magma is mostly solid. The US Geological Survey maintains the alert level at normal, and they are almost certainly right. But normal at Yellowstone requires careful definition. Normal means up to 2,500 earthquakes every year. Normal means the ground rising and falling as magma shifts miles below. Normal means hydrothermal explosions that throw rocks into parking lots. Normal means geysers going dormant for years and then reactivating 40 times in a single month. Normal at Yellowstone would be an emergency anywhere else on Earth. The Norris Uplift Anomaly paused in January 2026. The ground stopped rising. The earthquakes quieted. The US Geological Survey noted the pause in their February 2026 update and reported that activity had returned to background levels. But think about the timeline. The last time the anomaly appeared, it lasted 8 years. This episode ran for 6 months. Nobody knows if it will resume. Nobody knows what the pause means. The snow across the Caldera is too deep for satellite radar to see through until spring or summer 2026. The GPS data from late February 2026 is ambiguous because winter weather disrupts the signal. Right now, in this moment, the monitoring network is partially blind. The most advanced surveillance system ever deployed on an active volcanic caldera cannot see clearly through 3 feet of Wyoming snowpack. Scientists will not have clean satellite data again until the melt. Somewhere 9 miles beneath the Norris Geyser Basin, something accumulated enough material to push the surface upward and trigger 100 earthquakes. And then it stopped. Or it paused. Or it is building pressure for the next pulse. The instruments cannot tell the difference yet, and they will not be able to until the snow melts. Yellowstone has 10 times more seismic activity than anyone knew. 2 magma chambers with enough melt to match the last 3 super eruptions. A fault on its southern boundary that has been locked for thousands of years, while the volcanic system beside it continuously shifts the stress on it. And a hydrothermal system that is demonstrably changing behavior in real time. The caldera breathes. The fault waits. And 4 million people a year walk between them. Yellowstone will produce another major event. The geological record makes that unavoidable. Whether it is a hydrothermal explosion, a major earthquake on the Teton or Hebgen Lake faults, a lava flow, or something the models have not yet imagined, this system will act. The only questions are when, which kind, and how many people will be standing on it when it does. In 1959, 250 campers were sleeping 20 miles from the caldera when the ground broke. 28 died. Hundreds were trapped. The hydrothermal system was rearranged overnight. That was with a fraction of today's visitors, on a fault no one was watching, at a time when the monitoring network barely existed. Today the park has seismometers, GPS stations, satellite radar, webcams, and an AI system that just revealed 10 times more seismic activity than anyone knew. The monitoring is better than it has ever been. The real question is whether we will recognize the warning signs in time, or whether we will look back and realize that the warning signs were the data we already had. If you want to understand the disasters that do not announce themselves, subscribe. This is a story that is still being written.